Well, good morning, everyone. To all of you who are able to wake up in such an early morning, I would really very much like to know who the organizers are so that I can express my true feelings to them about such an early start of a rather important session. One of more interesting, well, all sessions are interesting, but I think, in my opinion, this one is rather hot, rather even controversial, if you like, in all aspects, in economical, ethical, legal, and so on. So I would like to introduce now our first speaker of the day, Mr. Sasha Vražić, who represents 50% of Croatian unicorn companies. He is from Rimac Technology, and he's leading the development of autonomous driving there. So I would kindly ask Sasha to give us his presentation.
Hello, good morning, everyone. So I will start. Some of you will have a chance to visit Rimac Technology or Rimac in general tomorrow. But for those who are not coming tomorrow, I will just make a brief introduction of a company. So this slide is just a representation of the automotive industry in Europe. So all the dots are supplier plants and the stars are assembly plants. And Croatia, which is the small part here, you see there's absolutely nothing. Until Mate Rimac started the company in 2009 in a garage, changing his combustion engine into an electric motor, and then start winning races with his car and gathering the money. He founded the company with the aim to create the fastest fully electric vehicle in the world, and also provide technologies to other partners. So that was in 2009, 0 employees, 0 revenue. And today, actually, we are about 2,500 employees. That's a certain amount of revenue. Beginning of last year, beginning of 2022, we carved out the company originally called Rimac Automobili into 2 companies, Bugatti Rimac, we'll say a few words later, and Rimac Technology, which is the supplier of a component. And this image that you see is one of the biggest projects in Croatia. In terms of real estate, it's the campus Rimac is building close to Zagreb. Right. So 2 companies, 2 businesses inside the Rimac group. Bugatti Rimac, with the aim to develop hypercars. So very, very limited amount of vehicle, very exclusive type of customer, right? People who can afford vehicles above $2 million, usually. So here, so the aim of this company now is, of course, to produce all the Rimac vehicle, the Nevera, that we will just introduce in the next slide, and all next Bugatti, the famous Bugatti brand, and their all next vehicles. And there's a part of a business, which is a different company called Rimac Technology, with the aim is to provide core technologies to car manufacturer in general. So the main focus is in the electrification, so providing full battery, axle, powertrain, but also technology like autonomous driving, control system, and such. So the Nevera is the world's fastest hypercar, fully electric and homologated. That's very important because there's a lot of vehicles that are fast but not homologated. So we were wondering how we can help our customer to master this vehicle. This vehicle is very powerful. I would not say dangerous to drive, but you need to have some skills if you want to go above a standard way of driving. So that's why we're thinking how to introduce autonomous driving to support the learning of the drivers to master this vehicle. So we equipped the vehicle, and I hope you will be able to see it tomorrow in our plant, with a lot of sensors, and it's ready in terms of hardware. We wanted that it's ready for a full high level of automation. So we have 13 cameras looking all around the vehicle, using mostly stereo vision also. And we have 6 radars all around the vehicles, and we have a very strong computing unit. But we struggled also to equip with a LiDAR, for example, because we need, at such price, the design is very important. So you always need to compromise between the positioning of the sensors and the design. And for example, we couldn't package a LiDAR due to the design, right? So what is the product we developed with this autonomous driving? We call it the driver coach. Imagine the idea. So you own a car and you go on a racetrack where you need to master a certain amount of skills. So the vehicle recognizes the track and says, welcome on, I don't know, Silverstone, for example, in UK. And then the car proposes you, do you want that I demonstrate you what you have to do? And that's a fully autonomous demonstration. So you're on the track and you are totally guided by the vehicle. It's driving autonomously at a speed or performance that you can adjust as you feel comfortable. And while this is totally automated driving, you receive in your helmet, because on the track you need to have a helmet, a 3D audio feedback. So instructions, what the car is doing, all information about, for example, braking instant, steering instant, and so on. And you have also visual feedback on a cluster, for example, of a vehicle. When this lap or 2 laps are finished, for example, the session is completed, then the car can tell you, now it's your turn, show me what you can do. And during this time, our AI supervises the driver and analyzing the skills of a driver and classifying it through the beginner to a professional by looking at the braking capability, throttle, steering, trajectory, and so on, and of course the speed. Once the session is finished and we are able to classify you and find out what is your skill or your performance level, we can generate tailored training sessions. And you can practice and improve the skills exactly where it is needed while lapping. And you have another way to improve your skills, to go even further, is this live coaching, where you have dynamic coaching instructions that are depending on the performance you are driving, for example, the vehicle. If you are not driving fast enough, you may not need to brake in a corner, for example. So you will not have a marker that indicates you a braking point, or you will not receive auditive instructions regarding any braking points. But it's also dynamic depending on your cognitive load. Meaning that if you are overwhelmed, for example, we will adjust the amount of information so you can still cope with what you have to do and limit the danger. And in the background of all of this, we have developed an active safety system that is for racetrack. So today, in all this autonomous driving element, you have, of course, the today it's deployed up to level 3, let's say, on most of the vehicle. Of course, robotaxis are level 4, still in testing, but you do not have this type of active safety does not work on a track. And I will say a few words about that later. So if we detect, for example, that you are not braking at the good instant, we will take over the control and brake for you. If you do not brake enough, we will give a brake boost, and the same is for the steering. And of course, we introduce a part of gamification that's engaging and analytics, but I will skip this part. So, what do you think are the challenges that are for developing such autonomous driving, and how far are they from the road autonomous driving or level 4 robotaxi system? Actually, it's very similar. There are, of course, some difference, and I believe that although it's not the same target, what we're doing is also extremely challenging. So one of the aspects of the challenges are in the scene understanding. Scene understanding is understanding what is happening around the vehicle, but it's not only important to detect what are the objects, is to be able to predict the future. And that can be really tough, especially when you have some blind areas on a track. But also the localization. If you think that we are racing, you need to have a racing line. To have a racing line, you need to use all the width of a racing track. And for that reason, you need to be localized very precisely, usually below 10 centimeters or less. And for that, using the standard GNSS approach is not really working. So we took the part of working with camera-based localization system to try to solve that aspect, because we need to be robust to mostly any condition while you are driving. And the control and the motion planning, right? So you can imagine the scenario, you are alone on a track, so you can have an optimal racing line, but usually you are not alone on a racetrack, so you have a lot of other competitors. And depending the strategy, if you want to really race, then you will need to dynamically compute the optimum strategy, which is always changing depending what is around you. And one thing that we really have headaches with is the safety metric. So, you know, on a road it's pretty clear, it's well established, mostly about the safety metrics for road usage. However, what does it mean for racing, right? If you are too conservative, you are not racing. And if you are not conservative at all, you introduce a high level of risk. So there's a compromise here, and there's a totally different approach about the safety metric and understanding even what is happening and monitoring the behavior of opponents, I would say, on a track to minimize the risk. So the vehicle, it's not only sensors that you need to equip, but you need to make it possible that you can control all the elements. That goes from the steering, the brakes, and the powertrain. Right. So once you are able to control that, that's special parts of a vehicle and special additional software or supplier are needed to this high level of autonomy. And we are developing internally these 4 core technologies that I will pass in the next slide. So from the perception, the driver monitoring, the localization and mapping, and the motion planning. But just before going to that, it's how we develop. So we need data, right? And this data, we have a small fleet of sports cars that have the Kia Stingers, and we have our Nevera car. We have just one. Well, it's a very expensive car, but I'm very lucky. I'm the only department in the company who own a Nevera, so we can play with it on a track. And once we collect the data, we annotate them, but that's, that's a heavy process. Another way is what we're using in simulation. While you use simulation, you can build scenarios and get the ground truth of the data automatically. Right? And we are doing software on the loop development for all the core technologies. We're doing hardware on the loop to ensure that all the processing are executed in real time. And for example, we are also not allowed to put a piece of software in the car if it's not tested in what we call this vehicle in the loop. We have a big room where we have, I would say, the body of the vehicle and all the controllers inside the vehicle, and we can test a software. Of course, you cannot test autonomous driving in a room, but you can test all the interaction with the other entities of a vehicle and solve, let's say, the first problem in terms of communication and the first bugs, right? And then once we're happy, we are testing on real racetrack with our team of pro drivers. This is the racetrack that we visited. It's mostly in Europe, about 26 tracks. All the most important here this year. Still, by the end of the year, we plan to go to US, and early next year, probably to Japan. So, the perception, detecting the object. So that's one thing. So you can think, but what are these objects on the racetrack? And they are probably very different than on a road. Yeah, you have very similar objects. You have pedestrian on a racetrack, actually. You have vehicles, but you have roads, but you have things that are new, like the curbs. You have similar things like the poles, but you have racing flags, racing lights. You can have, for example, a safety vehicle coming if there's an accident. And you need to be able to understand what's happening, especially when you drive autonomously, right? In terms of localization, so you see that's the same track, but taken at 2 different instants. You see also one, there's no cloud, weather is a little worse. And what I want to show here is just that we can track the feature between these elements to be able to localize us precisely below 10 centimeter. But mostly, as the task of mapping, it's quite an expensive task because you need to go on a racetrack. Usually you need to rent the racetrack for yourself, so it's pretty expensive. So one way we do the work is we work in simulation. And what you see here is the same track. On the left side you have a real world, and on the right side you have a virtual world. And you can see we can map some features and understand then where we are in this virtual world. So this, for example, help us for tracks, for example, for the Suzuka racetrack in Japan or Laguna Seca in US, where we do not need to go to map the track. We can either purchase the track and work on it, and when we are happy, we go on the track and we tune or finalize the development of the algorithm. In terms of driver monitoring, we are doing actually a lot of things. We're trying to understand the physiological and psychological status of a driver. So here what you see on the left side, the person were in the simulators. We collaborated with Leeds University. So we generated stimuli, visual and auditive stimuli, and we asked them to react, for example, to take the corners at a certain speed. And what you could see is, and we had two groups of people, professional drivers and amateur drivers, and here it's a professional driver, and you see that he didn't really behave well under certain stimuli. And this helps us to understand the cognitive load and then improve our user experience inside the vehicle and improve the safety also, because we know what type of instruction we need to provide at the right moment. But we, complementary to, or additionally to the test in a confined environment simulation, we did the same test on a real racetrack. We asked some driver, professional and amateurs. So this racetrack is pretty safe. We asked them to do the laps the best they could, and we generated stimuli. We asked them to double blink, you see, and they had to answer to some auditive messages. And we, using an EEG, we measured the cerebral activity and found out where are the negative emotions. We are very interested in negative emotions like anxiety, stress, for example, but also the cognitive load. So in terms of mapping, so we do some part of the mapping ourselves, because not all the tracks, for example, are available for purchase. So we use the drone, and thanks to the drone, we launch the drone all around the track, and we use the photogrammetry approach to create a model of a track. So that's the track that you saw before, and once we have this 3D model, we can integrate it into the simulator and drive the car, and then work on the racing line and so on, and make it more and more complex. So for example, this is a track we didn't go yet. It's Laguna Seca, but we're still already working on Laguna Seca. We drive the car, for example, in this situation alone. But in the next slide, I will show you that we can reproduce exactly what the car sees. So we model inside the simulator our cameras, for example, and we can generate virtual image, photorealistic image of what the car sees. So this is also in Laguna Seca, but here you see we have other vehicles, and we are working on avoidance or real racing algorithms. And why is this also important is by generating these images and using the simulator, you can create scenarios that you can spend years or maybe never caught by just driving and trying to collect this data, right? That's the age problem. And we use this virtual images to train our models, for example, mixed with real data. So in a mixed environment, and this improves all the algorithms. And when we are happy, here you see, for example, on a Stinger, so I will not show you it fully, but that's the racetrack that you saw before. For example, that's one of the tests. So the car is driving fully using the width of a racetrack, the full width. And what is important is working at the limit Working at the limit means you saturate the tires. You take the corner the fastest possible, so you maximize the lateral acceleration. And by doing that, you are using the tires very much. And after, I don't know, 5-6 laps, the tire, the gum are damaged, and your brake also. And the autonomous system needs to understand when this is happening, because if you are not understanding that, you will use the same speed to enter in the corner, and then you will miss the corner. So you need to understand the degradation that is occurring in a vehicle, so you can keep lapping and lapping, and you need also to understand when, so this is, for example, the example on the Nevera. It's a little more impressive. So that's close to Zagreb. It's not a racetrack, but that's a proven ground that we own. And we reach this small straight line. One lap, it's 950 meters, and we reached the end of straight line at 170 kilometers per hour. So it can be scary, but here is just to show where we are in terms of technologies. And we ask ourselves the question, but where we are compared to professional drivers? And for that, what we did as an experiment, we selected 5 professional drivers. We asked them to go on the racetrack where we were developing. It was one that you saw some videos already. And we asked them to do 5 laps, continuously 5 laps, the best they can to get the fastest lap time. And they use the same vehicle as the one that is the autonomous one. And we did the same for our autonomous system. So the autonomous system here is the black dot. And what you can see, for example, here is we are second, right? The autonomous vehicle is second, and you see that in this corner we're overtaken by the pink dot, and then we are faster. So in the next lap I will explain that. And the blue driver is a killing driver. He won a lot of races. He's a champion. So that part, you see, we cannot beat him. But what is important to understand is our AI system strategy was different in this final corner than the one from the pink driver. So when reaching this corner, the strategy of the pink driver was to enter fast and exit slow. And our AI decided to enter slow and exit fast. And that was actually a winning strategy because we could overtake him or be faster than him. And what you also see in this table is that at every lap we improve our time. We stabilize, we understand the tires are getting hotter, warmer, and we improve our time. So we didn't win at the end, we finished second, but it's really a great result. And one other understanding is what we have is that professional drivers, after a certain amount of laps, they start doing small mistakes, right? Losing a little the stability of a car, or actually you're always playing with the stability with a car, so sometimes you are oversteering, the rear part is moving, or understeering, while the autonomous system is still keeping the things constant. So we believe that if we did 10, 15 laps, we would finish first, and that's all VM here. So that finishes my presentation. Thank you for your attention.
Okay, thank you very much, Sasha, for your impressive presentation. I would like to now call our panelists. Well, in school we were called upon in alphabetical order. I will now just change that to counter alphabetical order, and I will ask Professor Kumare Sinha from Purdue University, who is Distinguished Professor of Civil Engineering and who's been active in teaching, research, and practice in transportation systems, planning and engineering for over 5 decades, and who is returning here to Croatia after many years to give his initial pitch.
Okay, so your presentation is this one, okay. You'll use this, okay. Okay.
Okay. I guess that's the reverse alphabetical order. Yeah. Well, thank you very much. It's an opportunity that when I was offered to me, I accepted happily because I came to Croatia several times in the past. First time I came, 1978, when Tito was still living. And then I came back in 1988. I was a Fulbright scholar in Yugoslavia. And then I also came 1992, but old Yugoslavia, but not in Croatia. I was in Slovenia. I could not come to Croatia because there was fighting going on. So I'm going to talk about what's going on in the United States, particularly, but when you talk about autonomous vehicles, we are thinking about not just autonomous vehicles in the context of electric vehicles, connected vehicles, and also some part of sharing how will be used. So my comments will be not just for autonomous vehicles, but all of them together. So in a short period of time I'll address few items, policy and planning, that we haven't done very well in that. The work is going on mostly on vehicles. There are 3 things: vehicles, drivers, and roadway. Vehicles work is going on very well, much advanced. The driver, some extent, is happening, but not much on infrastructure. So issue is really catch on. We need to do better demand modeling. Then also government regulation to protect user safety, improve user trust. But that's all will go with how much maturity taking place, the market penetration of these kind of vehicles. Liability, better definition of liability, road use policy. During the testing, it will be restricted use during that, like in San Francisco, that autonomous taxis being used in the night, although people don't like that because the vehicle stops when something it doesn't recognize, and people get mad because nobody can move it. It stops and sits right there. So also whether it will be used in dedicated lanes or certain roads. And also we have to think about that as autonomous vehicles come into picture, the rearrangement of urban land uses, like parking structures. Then, how does it go? Move to the next one.
Sorry.
Oh,
Okay. This one.
okay. And The biggest stumbling block of using autonomous vehicles is human factors. Perception. It's not when you give statistics, autonomous vehicle is this percent safer than regular vehicles, regular drivers. That doesn't help, because if you cannot control something, you're not sure whether you will use or not. If I can control something, even though there is a big risk, at least I'm in control. Leaving the control to a robot or somebody else is a different thing. So we'll have to have developed very detailed, much more in-depth the cognitive type of science into doing research in human factors. There are several things that there. I will not go through, read these things. We need to develop a man-machine interface, and the risk characterization, also how do we measure them? When does human take over during transition phase? Warrants for takeover warning modes, those are the things that's yet to be done. And as I said, vehicles we are working on well, but drivers and other human beings and infrastructure. I'm a civil engineer. I feel there is a lot of work to be done in infrastructure readiness. And it will, of course, depend on market penetration of each LOA, level of autonomy in the transition phase. There are few examples I have. And highway agencies, they will not spend money to do anything until they're sure it is needed. So we need a better demand modeling. So all of these things have to work together. And then eventually, as the transition goes on, new infrastructure types we need, and also retire existing infrastructure types. My next slide, this is I'm going to pole vault over and go to the future. If it all pans out, this is going to revolutionize the way we live. It is going to, well, first of all, we all know why we are doing this thing, to make the safety, to bring safety, because you have to take the driver out of driving to make it safe, and also cut down the pollution, GHG emissions, travel efficiency. All those things will make sustainable mobility, and that will improve quality of life. And quality of life improves means there will be increased capacity of urban and exurban areas, including rural areas, to enhance human interactions. When people come together, idea sharing, innovation takes place. So I feel that the time is coming of a new kinds of human settlements, new era, that will provide socio-economic vitality, increase economic activities, job growth, and creative pursuits. We'll be able to save time from commuting and put that into do creative pursuits. Maybe enjoy museums, spending time with children. Life will be beautiful. So I feel if this all pans out, there's a promise of urban Renaissance, new kind of living, and all will be better off. Now, my last slide, few things that we need to do in the meantime is the role of us, the researchers and educators, rigorous empirical and experimental research, like our speakers spoke about things going on. We'll have to do not only the laboratory research, but ground truthing, rigorous ground truthing. Educational resources to reorient, retraining labor forces, coordination of universities, federal, state, and local government. They're all stakeholders, and private sector, of course, to implementation policies and development of protocols. Now, we are in the academies here, so I feel there is a need for international cooperative arrangements through national academies and also professional societies. Because, as I said, if it pans out, there will be revolution in the way we live. Thank you very much.
Okay, thank you, Professor Sinha. I would like to call now Professor Ivan Petrovic, who is a full professor of the Faculty of Electrical Engineering and Computing, University of Zagreb. He is the head of the Laboratory of Autonomous System and Mobile Robotics, and he is a full member of Croatian Academy of Sciences and Arts, and also a full member of Croatian Academy of Engineering.
Good morning, everyone. Thank you for invitation. Thank you for coming so early. So I will, in a few minutes, say some of my thoughts. My presentation is quite general because I didn't know what, not like what we are doing in the lab, but I hope we will discuss, just raise some points, and then we will discuss, I think, in the panel. Okay, about first, autonomous vehicle market size, just general information. So last year we have about 21 billion US dollar, and the forecast is that in 10 years we have about 2,350 billion US dollars market, and that means that the compound annual growth rate about 35% in 10 years. Which is really remarkable. But what are the market drivers for this to happen and to introducing it, at least at all autonomous driving, is first is safety. You know all that human error is leading cause of accidents on the roads. Then efficiency, autonomy and connected vehicles could really optimize traffic flow, could be optimized, and congestion could be reduced, and fuel consumption could be improved. But of course, electrification is also, electrical vehicles also could help in this. Accessibility, that means that we could also enable improve mobility of people who are unable to drive due to disabilities, age, and so on. Productivity, I think that the previous speaker just mentioned that we could enjoy the time in the car, or we could do some work, entertainment, relaxation, spend, and so on. And also, cars, autonomous cars could also help in urban planning, the reduced number of parking space, improved land usage, increased focus on pedestrian environments, friendly environments, and so on. And what are the challenges behind those vehicles? There are a lot of technological challenges. That technology should be reliable in terms both on hardware and software, and to be able to handle complex and predictable real-world scenarios. Of course, we are all aware of regulation legislations. There's a need for introducing legal framework for reliability, insurance, and safety, and also harmonization of regulations across jurisdictions between many countries in the world. The different culture, different jurisdiction. Also, I think that convincing the public, I think that you also mentioned before, that trust to autonomous technology. You mentioned this taxi and the issue of this acceptance. We are now in transition period in front of us. Transition period where we have conventional cars and autonomous. We will have autonomous cars. This mixed use scenario on the roads. That means this is really, it could increase, really have potential complications I think the situation will be much more, let's say, easier, or when we have all cars will be autonomous in the future. And also cybersecurity challenges, because these new cars are connected and then highly dependent on connectivity, and that means vulnerable to cyber attacks. But also market opportunities. Introducing autonomous car, new business models also will become possible, like growth of new service-based businesses, like sharing platforms, ride-hailing, of course, for new autonomous car. Autonomous car also could be a source of huge data for different purposes, like to improve urban planning, transportation systems, overall efficiency, but also could be used by governments or some companies for different optimization. And autonomous car will also, I think, give opportunity for new jobs, for economic growth, like new jobs in AI development, sensors manufacturing, because new types and the new, a lot of new sensor, improvement of sensors that we use, because this really bring new opportunities for fleet management, but also for investment in smart infrastructures. I think that was also mentioned. Also, electric car, but autonomous electric car in future really could have big environmental benefits. And for aging population, I already mentioned that mobility will be also, independence in mobility will be also enabled for elderly individuals. So just on one slide, how they work, what are autonomous technology behind. So different sensors. Sasha mentioned they do not use LiDAR because of the, let's say, design requirement, but also radar, cameras, even ultrasound. It depends, but also this car should be connected, wireless connected. Maybe in the future, I expect that this not only car-to-car communication, but also we have cloud, where we have map for the city, and also edge computing, AI also very important. This stages of autonomy levels, autonomous level stage 3. Level 3 is, let's say, already, let's say, here, and now level 4 is approaching, and level 5 is long-term future also. But that when we have full autonomy, that means we can sleep in the car without fear. And here is some elements of from sensors, localization mapping, Sasha mentioned already, decision making, perception, of course, and object analysis, classification, detection, classification, tracking, and also I mentioned already cloud, where also cloud infrastructure and high performance computing will be very important. Here a list of topics for research challenges, from, let's say, technical ones, more on the left, and also, for example, on the right up, you see simulated test environment. Sasha presented his presentation how they using simulation, a lot of simulations, and then interoperability, human-centered designs, all this. But this we could discuss during the panel or questions. But I will just put on the last slide adaptation to global driving conditions. There are a lot of challenges still in front. Let's say, imagine how autonomous car could drive here on these scenarios. It's really difficult. Heavy rain, you see people mixed with cars, cars that flood, very snow, very and desert with a lot of dust and so on. This situation is really, autonomy is the technology that really now, let's say, when you think about standard, let's say EU city, okay, it could be bring, but let's think about situation, this complex, very difficult situation. Will we have autonomous vehicles capable to navigate in these scenarios? That also requires, what you mentioned, a lot of investment in infrastructure. So autonomous cars will require also investments in infrastructure, but this is also opportunity, creating new jobs and new opportunities. So this is all for the pitch, but then let's discuss later. Thank you very much.
Okay, now I would like to call the assistant professor Alexander Katriniok, who is with Eindhoven University, Control Systems Technology section, and he's been working also with the Ford Research and Innovation Center in Aachen, where he is involved in low-speed autonomy application. Alexander, the floor is yours.
Yes, thank you. Yeah, thank you very much. First of all, I would like also to thank the organizers, Nevin and Vedran, to invite me. It's a great pleasure, and also many thanks to Lucas to give me the opportunity to speak on behalf of ACTI, so the Dutch Academy of Technology and Innovation. Yeah, I'm basically working in industry and in academia, which is a great pleasure to me to see both worlds, to pursue new developments in the university with students, but also see what are the needs in industry. And I will focus a little bit more also on examples. We have seen a lot of challenges that are out there in automated driving, but we also have a lot of systems already on the road. And in your personal vehicle, you might have an adaptive cruise control system, a system that keeps the lane, right? These are more like level 1 or maybe level 2 systems where you combine longitudinal and lateral control. But recently, and I think Daimler is one of the first brands introducing level 3 autonomy, at least in Europe or the US, where you can really take your hands off the wheel and your eyes off the road for a limited amount of time. But you have, in a certain time period, be able to get back into the control loop. So the car tells you, hey, now I cannot handle the situation anymore. I'm out of the operational design domain, and now you have to take over again. But we see such systems already on the road, like the Daimler Drive Pilot, and more prominently, maybe even the Tesla Autopilot, which is not a level 3 system, but I call it level 2 plus, because the driver is still fully in charge of what's going on. So many might think, because of the name Autopilot, that's really a autonomous system, but it's designed such that the driver has still full control over what's going on. But we can also see level 4 or level 5 systems already on the road, like in the US. So Waymo, for example, it's a subsidiary of Google, has rolled out a quite significant fleet of vehicles operating in San Francisco, for example. Same for Cruise, which is a subsidiary of General Motors. And I mean, these systems are on the road, but some strange and interesting things are also happening. I don't know if you have followed the social media, but I also have one interesting report from the social media on my next slide. So essentially, what I wanted to say is that we have seen many technical advancements during the past years, and we have also seen in one of the previous talks that there is a huge market potential. This study is from 2019, maybe a little bit more optimistic than maybe industry would be today, but I think the message is the same, and we have seen it also in one of the previous talks, and I checked it, the numbers. Basically, this is the number of cars that is going to be rolled out in the market. The other slide was related to kind of the monetary perspective. But basically, well, we can expect 10 times the vehicles that we have in 2023, that we will see 10 times the number of vehicles in 2030. So there's a significant market potential for those vehicles. And we can already see many of them on the road, right? But one could say, well, what is still there to do? And we have heard it in the previous talks already. There's still a lot to do, not only from a technological or technical perspective, but also from a legal perspective, ethics have to be considered. We have heard that infrastructure also needs to be considered. But also a lot of things can go wrong, right? We can see basically that cruise vehicles or Waymo vehicles are operating quite well. You can see on LinkedIn videos from influencers that call a vehicle, drive from A to B, and everything works quite nicely. But I like this figure here from Tesla, and it basically says it's all about the long tail. So what does it mean? Essentially, in many cases, let's say 99.99%, everything goes well, but there is a small percentage of cases which you don't expect and which can go wrong. So for example, in perception, if we have camera systems, the camera system is not trained that a bicyclist carries a stop sign. So there are very interesting pictures on the internet, you can check it out, where you can see cases that are not supposed to be trained in an automated vehicle. And the same is for motion planning and for every other domain. So we're still facing a lot of challenges, among of them, and I cannot count all of them, I just choose a few ones, maybe focusing a little bit more on the technical aspect. Our sensing and perception, I already mentioned it. I mean, what you can see is basically that these scenarios here where a car flipped over, there's a car on a trailer. There are a lot of things where an autonomous vehicle could draw false conclusions. We also have decision making and motion planning, which is quite complex. I see in industry that many approaches are still heuristics, right? And if you want, from my personal perspective, exploit the full potential, you may want also to look into optimization, into machine learning, and many questions arise also there. I mentioned before, we think that a lot of things have already been solved, but here is a post on X, formerly Twitter, where the robotaxis in San Francisco got stuck in one single road, and interestingly, there were like 30 or 40 vehicles of Cruise all in the same spot, right? And they could just basically get rescued by human intervention. So although these vehicles operate quite nicely in this environment, there is still a low chance, let's say a long tail of the distribution where there's a low probability, but there are a lot of cases that can go wrong. We also have compute power. If you want to apply more sophisticated algorithms that use machine learning or optimization, we have to solve those problems in real time, right? And also machine learning, I mean, that can significantly reduce your battery charge. So if you have to leverage a lot of compute power, what does it mean? You have 200 kilometers less in range. Is that acceptable? So how do we handle all those things? And that relates also to energy efficiency. But also, how do we combine decision making and motion planning with efficiency aspects? What you can see also in industry is that many motion planning problems focus on the motion planning itself and not so much on efficiency. So there is also a lot to do, and we have heard it in the previous talks that legal and ethical aspects are of high importance. We don't have to forget the human, which is still there and which is a very important component of the whole control system, although the system might be automated. So for the upcoming discussion, I decided to come up with 3 questions that kind of move me the most in my everyday life, in industry, but also at university. And would also be very interested into to understand the position that Rima, for example, has in that regard. So how do we solve decision-making and motion planning problems subject to environmental uncertainty in real time and for serious production cars, right? As I said, in industry, for example, for autonomous parking systems, you see a lot of heuristic approaches still, but they cannot exploit the full potential. And so the question that I would like to raise is also, is numerical optimization combined with machine learning a game changer here? Or do many peers think that such methods are not tractable in series production cars for many reasons. Also, how do we ensure that automated autonomous vehicle operation is efficient and sustainable? Because as I said, in industry, you see very frequently, and also in academia, predominantly a focus on how to operate the autonomous car to get from A to B, how to take decisions, but very frequently efficiency is not necessarily taken into account, and how do we combine these two aspects? And finally, it's a little bit of an overarching question. I think it was also kind of covered by the previous talks. I'm asking myself, how do we interact with the transportation system, right? I mean, motion planning kind of focuses on a single vehicle. A little bit selfish, I would even say. How do I get from A to B? But if I want to interact with the transportation system, I somehow maybe have also to sacrifice my own goals in order to achieve an overall improved efficiency in terms of traffic flow, in terms of energy consumption in a road section or in a confined environment. And also we can think about vehicle charging. So if I have electric vehicles, where do I charge them? How do I avoid grid congestion, for example, that I don't charge all the vehicles at the same time in the same place? So there are a lot of things that are still open, and with that I would like to finish my pitch. And if I may, just two points that I wanted to mention. If you're interested in these two topics, from an academical perspective, we have a special issue also on automated driving, and we'll have a conference in the Netherlands. Please feel free to reach out to me, and I'm looking forward to the upcoming discussion. Thank you very much.
Okay, thank you. And last but not least, Professor Subhasis Choudhury, who is with the Department of Electrical Engineering at Indian Institute of Technology in Bombay, and he is a fellow of all kinds of Indian academies that exist. Please.
Okay. Thank you. Good morning. My great-grandparents kept a last name, thinking I'll have the alphabetical advantage, but since I'm talking at the last because of my alphabet in my last name, I think, if you look at all the good things have been said already, and all the problems that, the issues that need to be done has also been, they've been mentioned. So what remains for me to talk on? Okay, so let's look at certain challenges that I would say. Okay, the first is a spelling mistake here, I see, because, okay. So if you look at the typical problems, I think, Sasha has given a very detailed description. So I need to detect the object, whatever object means. It could be the entire scene or whatever the part of it. Okay. And life gets difficult when you go in a city and others, there are a lot of glass objects and others. So we don't talk about that, because then, you have reflections and others make life a lot more difficult. So, okay, so, coming to what Professor Sina said, that, it's infrastructure also should be conducive to what you're going to use, right? So that's, you should look at that. Then there are like many cars moving. It's not just my life, there are so many other cars, everything. So how do you actually manage the relationship between different cars and others? Then, of course, we talk about at the car there, I have to find out where I position myself, what is the 3D environment, all of them. That's like SLAM, what is it called? So it's to be done, and these are all in real time, okay? Then what is, I think, the last picture that you showed here, okay, was the inhomogeneous traffic. When things are moving in a very homogeneous traffic, similar kind of cars, others, okay? But imagine like, we talk about autonomous driving, and if you look at today, many of these DoorDash and other kind of delivery systems, they run, all of them are two-wheelers now. We don't talk about that, but the thing is that we need to change, because that's where is our primary thing, and that works at a lower part of the income generation process. So they have to give a better perspective. So they should be the first one to go into automation mode, right? Okay. Then vehicle control, I think very nicely, I think it talked about in the last presentation. And then the stalemate handling. I think this is sometimes you have a complete stalemate. Okay. So these are the issues that need to be looked at, okay? So in order to do that, I think in the first talk with the RIMAC, I think they said that they don't use a LiDAR. But the LiDAR is actually a lot more accurate, okay, in terms of data, and you can acquire data a lot more easily. But the problem is the cost, okay? The cost goes up, okay, and sometimes if you want to reduce the cost, it's still about, I would say, $50,000 minimum, something like that, okay? Then what kind of system that actually fit in? Nowadays we talk about like CPU, GPU, FPGA, or whatever ASIC, different kind of thing. Now the reason I said that it has to be done fast, and people have talked about perception, right? So here we are talking about, let's say, level 5 or whatever, So in that case, you also need that latency is very important. How do you reduce the latency? Now, if you go for like CPU and all usage, then of course, latency would be very high. So you have to actually go into something which is like your GPU would make it faster. But what happens is that you have to pay a lot more in terms of energy, okay? So ASICs and others, it's very specific to that. So the mass production capacity may be less unless you have, thousands and thousands of such things. But that's very important when you go for, autonomous driving. The heat dissipation. Now what happens is that if you use GPU or something like this, there is a tremendous amount of heat gets generated because they work at a high speed. Similarly, your car is parked and anywhere outside, on the sunny days, sometimes could be 40 degrees, okay, in centigrade I'm talking about, okay, or it could be much cooler. So in that case, this heat dissipation is actually one of these things is that this car has to be cooled, okay, and that means you have to actually, there is a loss of power. Because yesterday we had this battery power, when you talk about that. So we see that something like, up to 15% of your power goes into actually handling this. Okay, so this is completely useless in terms of your actual usage, but you have to do it, otherwise your system will start malfunctioning. Okay. Sometimes the Google map or something, whatever you are using, it's completely ridiculous. Once I was driving and I in an unusual place, and I said, okay, how do I go from point A to B? It took me somewhere, and then later on I find that it's actually for the two-wheelers, not for my four-wheeler. So I got stuck. I had to, so how do we know that this is safe? Okay, because finally it has to trust something, right? Now, building sensor redundancy. See, any kind of system that you have, okay, so we have some system redundancy required. Now, the moment you do the redundancy, now the system fusion level information that is required at the same time, your all this power level, computation time, everything goes up. Okay, so that adds like a cost to your system. Then of course, the ideal case is that nobody drives, it's all fully, level 5. Then they are all, I could have vehicle to vehicle communication. So that's definitely very good, okay? Because then a lot of these problems get sorted out automatically. I don't need, to solve a lot of difficult problems, but the trustworthiness could be an issue because it can be hacked, and one injection could be a difficult one for, like a mass, collision or something like that. Okay. Then lane markers, many places, like even in India, you see that sometimes it's not there. Okay, so which is actually one of the good things for you to guide your, system. So you have to take care of that. Okay. Now also many times what happens that, there are traffic lights, it knows very well as of today, but sometimes because of construction and others, you put a traffic warden instead of light, and the system doesn't know how to handle that because there is a person who is guiding or left, right, or stop. It doesn't know that. So what is the after effect if you look at that? Okay. Now, autonomous driving, when you do, this reduces the battery power, because I told you like it takes about 15% or so. And this doesn't involve like redundancy. If you include redundancy, let's say even when you look at camera versus LiDAR, okay, so camera, some of them are using simple few cameras, okay. Tesla uses I think 7 or so, and I think Rimac, I'm happy to see like 12 of them, right? So that's, but there's a price to pay for that, okay. Things become, of course, you were just talking about fast and furious. I think that's the way to say that. Okay, it's a good thing, but somewhere else I'm paying for it. Okay. Now, many times what happens when you have a single lane system, okay, this is like, it doesn't know whether I am actually blocking a lot of other people because I'm at a slower speed or something that I can handle. And many times you know that you move to the curb and you let the other people go, okay, which is a good social behavior for us drivers. But this system doesn't know that, right? So it'll keep on obstructing the rest of the traffic, which could build up over time, okay? Now also, this leads to another issues that many times what happens that if any malfunctioning happens, unlike in human, okay, I know there have been cases that is reported while driving, that somebody was driving a bus driver, okay, and the person had a heart attack, okay. Now when that happens, even if it's a heart attack, serious heart attack, you get, maybe a minute or so to respond, right? So there have been cases where they moved the car, okay, saved the life of another 50 passengers. But typically any electronic system, when it stops from, the malfunction happens, it's almost immediate, okay. So if something happens, then what is the recovery mechanism? Although of course we talk about redundancy, but definitely this is an issue that we should look into that, because the recovery, the safety cannot be compromised, okay. Then of course, then car can become the good thing. I think you talked about this is basically the shared collective property of the community rather than being an individual, which is very good because there's an optimal usage of our resources, which is definitely good. But there's another issue that happens is that finally it will not be only Rimac, there will be Tesla, there will be so many other cars that are there in the market, right? Now, when I go and I'm allowed to drive, there is something called driving license, driving test. So we have to pass that exam, right? So that I can be trusted to be given the license. Now what happened, the licensing mechanism, that because I may come out with my lab and work out something and put that car over there. So what I mean is like it's a standardization of the system. So as of now, I don't see any kind of standardization that has evolved so that if your car actually meets this corresponding thing, then you are allowed to be on the road. Otherwise you are not, okay? Because what you see in the SFO, the streets, these are all like an experimental demo pieces. They're not, they've been allowed, but when you have so many companies, you need to make sure that this is properly taken care of, okay? So I talked about, so that's like a certification, and other thing is I talked about the hacking part of it, because when everything is a level 5, is we are connected network and everything, so how do you actually stop this one? But at the end of it, okay, so we need sometimes, somebody buys a car, somebody buys a big car, okay, fancy car. So what is it? Like finally is the fun of driving. We love the speed, we love the thing. Now supposing we leave it outside, of course there is a sacrifice we are making, but sometimes I think I think Rimac, you will allow me to drive on a regular mode also, so I should have that also. So that's definitely good. But what we are looking at is a world tomorrow where is connected, okay, where things are safe, where it is not like an individual, it's a collective system, and based on that, maybe we can have a system which is a lot easier to handle and it will satisfy the needs for tomorrow. Thank you so much.
Okay, please come. It's time for the discussion. I don't know about you, but for me, this presentation were very interesting. Please sit. Where, Sasha? You are the main star of this panel. And just a question for you. When I mentioned your name, I noticed that on the steering wheel there was a KIA. What does it stand for? Killed in action? That KIA in your video on the steering wheel. Really? I'm curious. Is it a Kia car or?
Yeah. It's really a Kia car, yeah.
Okay, so it was not Nevera.
No, we're using the Kia. Actually, it was a choice because, you know, we have shareholders inside Remats that are part of Hyundai and Kia Group, so we could benefit of that by getting all the information how to control the car. Actually, we started this project, I can say, by hacking a Renault car, because we couldn't get the information from Renault how to control the car. But actually, so hacking was easy, but it's dangerous at the same time because you do not know what really the system is doing. Right? You do not know what the state machine of a vehicle is doing, and you are trying to send commands. And we had some issues, right? When we sent a braking command and it didn't happen, we did not know why. So that's why we purchased the sports version of the Kia car, and we could get the easy access to control.
Okay, and while we're handling the mic, the Nevera, who is it made for? What is the purpose of the car? Is it for racing or is it for driving on the road?
Yeah, that's a good question, actually. And not everybody will race with a car, definitely. It's a car for car lovers, for collectors, for exclusive clients. It's a showcase of what the company can do in terms of technology. So you have the whole electrification. So it's the highest power density battery pack that is inside. So, and this actually made the company famous, and it's one of the biggest provider to all the automotive industry today, actually, and something we can be proud of. And it's the same for the other technologies like the powertrain, the infotainment, the autonomous driving. So the main idea is to provide that to supply others.
Okay, thank you. And one last question for you. Do you see the future in the racing of autonomous cars? I don't think that's very amusing. It looks to me like, for example, watching porn where robots are acting.
Yeah, well, actually the autonomous racing, it's an activity which is developing. And there's, I don't know if you are familiar, but for example, in Dubai, there's a Yas Marina racetrack, and there's a famous racing challenge where the first prize is $2 million, actually. So there's a lot of companies and a lot of work that is done, and the work, because also the work that we are doing here in Remats and this technology that we are trying to build can be used for road and can help to solve, for example, emergency situation on a road where the standard approach of the manufacturer of level 4, level 5 system are not really considering such high emergency situation where you have, for example, for recently, a cruise situation where a pedestrian flew in front of a car and the cruise vehicle, robotaxi, couldn't stop and drove on it and then remain on the person, right? And maybe some emergency techniques in terms of control, a vehicle could reduce this type of injury. I don't know, but the idea of what we are building, and universities are a lot working into racing, autonomous racing. There's the Indy challenge in US. And that helps the community, actually, the scientific community and the industry to improve the algorithm.
Okay, thank you. Ivan, you are closest to the mic. You mentioned that this autonomous driving will create new jobs. Aren't you afraid of that FIST union of truck drivers in US who are capable enough to overthrow a president of the States so that they might object about introduction of, what about all those Uber drivers, Bolt drivers? What will happen to them?
Yeah, that's also a concern. Okay, generally, every new technology really due to have two causes. One is that many jobs are actually disappeared, but new ones are created. So that means new jobs, as I mentioned, AI development. That means we need to educate people, new people on this, and then on sensor manufacturing. That's really, cars are really the main end user of for sensor technology companies. But now this become a little bit much more. The market will increase significantly because these sensors are more complex and more expensive than standard sensors now in the car. So also this is opportunity for new jobs for infrastructure. We need also to build a lot of infrastructure work in cities and to enable this autonomy, to full capacity of the autonomy. And then, for example, this autonomous car actually could drive level 5 or level 4, level 5 in future smart cities that everything is connected. So that's, I think, open new jobs, but in different types of jobs, yes.
Okay, and I'm glad that you mentioned urban planning for family reasons. I know something of urban planning, and I would say that at least here in Zagreb we are doomed. We should really switch to some other enterprise than autonomous driving, if it depends on urban planning.
Yes, please do. Okay.
No, I think, no, I beg to differ to some extent the kind of thing that you were saying, that because if I look at India, there's more than 10 million people who livelihood depend on, this kind of transport system, whether it's a taxi or like, big vehicles, whatever. Now, suppose you say that I don't need them, maybe whenever it happens, then this 10 million people have to be shifted from somewhere, from this particular job to somewhere else. Now, if you say that the same industry, like if you look at generating this such kind of a technology that drives this, so definitely you don't need 10 million people to do this autonomous the system. So they have to go into creating some other kind of opportunities. So you have to have a complete different sociological, development in the system to say that these people can actually be done, because this is the complaint that today we get, that you have growth but no job creation. And that's whether we fall into the same loop again. I think that's what my comment is.
Yeah, I understand your concern. Actually, when you look back to this industrial revolution through time, always it was, that always the similar questions were raised. But I think that okay, maybe the fear is a little bit more. Have more sense now because these changes are happening so fast, and then it's difficult if someone is 50 years old, and then difficult to let's say educate him, train him to be capable to do something else. That's true, but still I think logistics, maintenance of these vehicles would change. Let's say, I don't know, a few months ago, I know that in Paul Zubak, one of our car dealer, they also opened a school for training new workers for maintenance the electric vehicles. And so I think maybe it's always a challenge. But what is the other option? Maybe I think that for future generation, if they are not trained in new technologies, then we will stuck in place. We need to go forward and find another option how to let's say, maybe people are not with 55 years old, if they can't be trained, we could some social measure introduced to help them, but not to stop the progress. You may, yeah.
This fear of losing jobs is not just in transport area, automation, AI. The film industry in Hollywood, the writers and actors, they're protesting. One of the things is AI, fear of AI. And then also in the automotive industry, the strikes going on. they are same thing, they're afraid that electric vehicle will take their jobs away. This is as exactly as he said, industrial revolution, Luddites, they're breaking up all the textile little spindles. But so, of course, there will be some upheaval.
I think it's a bit different. I think today in AI there is a lot more of A than I. I think that intelligence is not very. You know the joke, I suppose, all of you. Well, if you are afraid that you'll lose your job to artificial intelligence, then your job didn't need any intelligence to begin with. And that person said, I didn't understand. And the other one said, you are safe.
Okay, that's good point.
So, to continue, to leave, of course, some time for the questions for the audience, I would like to ask Alexander, he mentioned malicious people and how to handle them, those people waving a stop sign from the bicycle. And I can imagine a lot more pranks that evil people can do to electric cars.
Yeah, true. I mean, it was not in that case that I mentioned malicious, but of course, a lot of things could happen where people try to kind of, try to provoke that things are going wrong, of course. So, yeah, I think a lot of training is required in those systems. You have to find out what are the edge cases. And I think key will also be to collect data on the road, to feed it back into the cloud, to do some retraining, to feed it back into the car. I think Tesla has also done similar things in rolling out, for example, a cut in a prediction, for example. If you want to predict if a vehicle is cutting into your lane, what you could do is actually that you run such system in shadow mode. You validate your predictions based on data that you see on the road, and then you can see, hey, yeah, it behaved quite well, right? So I think what I wanted to say is essential is that you collect data, you feed it back to get really all those edge cases that you can face on the road. I think that's a key component to it.
Okay, and how far are we from solving this trolley problem? You know that one. Kill a bunch of people standing on the right-hand side of the road instead of a single person on the left-hand side of the road.
That's the ethical question, right? That the classical problem. I think, I'm not sure if this problem has been solved or can be solved. That's a really difficult one. You don't want to kill anybody. So in the end, I don't know, you cannot beat physics in the first place. Maybe you can establish a safety envelope that is kind of makes your system more robust to things that you cannot foresee. In the end, it's a very difficult question to say. I don't want to kill the one or the other person. I think that's not going to work out.
Okay, thank you. And Kumaris, you mentioned liability. Could you tell us how far are we from any applicable law in that area that will really regulate who is responsible for accidents caused by electric cars? Autonomous cars, excuse me.
Tell me, what's regulate the...
Yes, we probably need the law, which will unambiguously say, okay, Musk will pay for all those accidents caused by Teslas.
I still didn't understand the question very well. You're asking me who will decide liability? Yes, those are the things needs to be defined. It's not very clear. I think what will be eventually the manufacturer will be responsible. I don't know, but those things to be defined. In case of accident, who is liable? Is the company that provides the service, or the manufacturer, or what? Or the person who is riding the vehicle?
And what is your best estimate? How far are we from getting such a law?
I don't think we are, nobody's thinking about that yet. I do not think that anything is going on.
But we are thinking about putting like autonomous
Oh,
cars on the
right
street.
now, right now, like Waymo taxi and those things, those who are the company, the Google, and they are responsible now for anything happens. But the way it is being done, like as somebody, I also mentioned, in San Francisco, the Waymo taxis in the night, they go around without any driver. But they're very cautious. Anything out of ordinary, the car just stops, and they cannot move. And the people don't like, but the traffic is backed up. So recently, one incident, a taxi got stuck in a firefighters. They tried to get rid of the vehicle out of the way. Nobody could move, and there is nobody, there is a central control, taking care. It takes about 30 minutes for somebody to come and move the car, or do something. So the firefighters broke the damn thing and move it.
So this moves us to the second question that you mentioned on your slides. So this stalemate handling, how will we do that?
It's a stalemate, no matter whether it's a chase or anything. It's probably the big problem. So until normal mathematical sense, if you say that you need some external kind of perturbation to move it out of that stalemate, I think that would be the typical mathematical solution. But what is that extra thing that takes it out of that stalemate, right? So it's not clear, right? So for example, like here, what happened, that the traffic backing up and the stalemate that created. So finally there had to be human, interference in terms of moving it. Now, if you have interconnected vehicles, possibility, I think we have to look at the issue is that the system doesn't go into the stalemate mode, right? Of course, there could be always issues but if there is a connected vehicle, and also in tomorrow's thing, I can take an example, let's say, for example, in Japan, they have this bullet train, okay? And they have, they run at a tremendous high speed, right? And then they're very safe. And what is the reason? Because they created separate track and all these, the points that they have to maintain the standards. Now, here also, when you actually create, in order to remove such kind of stalemate points, I understand that cars have to be a little bit more on the defensive strategy that they would play, not like a fast moving car. But what happens is that we have to give a lot more sensors along the street side, other things, so that basically they get the feedback from there. And there has to be like a rebooting of the system so that you know that now I can start again. So unless that happens, that needs a lot of change in the environment variable in terms of how you create the, I think you talked about infrastructure, the civil infrastructure where there are at the roadside everywhere, there are markers, there are some kind of RFID or whatever the kind of sensors, right? So those kind of things have to be there so that you move out of that.
Okay, and one last thing. I think it was mentioned only by you on your slides, the fun of driving. I hope the manufacturers aren't planning of removing the steering wheel out of their vehicles.
Yeah, I think it's always, for young kids, they say that the few things they always look at is my first car, my first house, things like this. And I think ever since, the human civilization has come up with this, automobiles, I think it's a great fun for people to enjoy as long as you're a responsible driver. And I think most of them, they do, okay, definitely. There are, of course, some rogue drivers. But that's something that, finally at the end of it, we talk about autonomy. But we have to live it a life which is also fulfilling and entertaining, okay? Now, if I miss out now, you're going to miss out one part of the fun. I don't know, at some point particularly, I thought, oh, what happened? I mean, if you grow up with a culture that this fun never existed for the new generation, maybe they're okay, but for people like us, wow, at the end of it, I said, why not take a spin, go out, okay, have fun. So that would be missing.
Okay, thank you. So I think, yes, please do.
This is a very important point. The things have happened during pandemic.
Maybe look with it
The
closer.
pandemic has taught us that it's not necessary for everybody to go to work, the commuting culture. Number one, that the automobile was used to go commute. And in particular in America, that I lived there for 60 years. That culture has changed. Not everybody, you cannot manufacture steel or do something that from home. But a good portion of the workers don't have to go to work. That's not that they don't like the office, but they don't like commuting. So that's one thing. Second thing, the new generation people, you know, my children, when they're young, they're 16, they could have a license. They were eager to get license. My grandsons, they don't care. My grandson, 19, he doesn't care to have a license. So that driving used to be a big thing. It's not anymore. And some of my children, they live in downtown, you know, they live in Central City, and they don't have automobiles. If they need the zip car or something of that nature, shared rides. So world is changing, and so maybe all automation, the innovation that are going on, all put together, I envision that we will have our living will change eventually, not today. Gradually, we are going towards that. That will allow us to live in close proximity to our neighbors and our neighborhood type of living that used to be 100 years ago. The fossil fuel fired automobiles destroyed the human scale of living, and that is going to be restored with that's my vision, that innovation in transportation, automation will bring us back to living in close proximity with our neighbors, and that will also cut down crime, and also it will add to conviviality and neighborliness. Life will be beautiful again.
Okay, thank you. So let's have some questions from the audience. Professor Barbir. And another one.
Thank you. I really believe that this is the future of driving. However, before we reach this future, there will be a period where there will be both drivers on the road and the autonomous vehicles. And not all the drivers behave according to the rules. So I have an example, actually a couple of examples. I lived in Istanbul for 3 years, and I know how people drive in Istanbul. And they have a rule: if you want to make a right turn on a highway, you don't drive in the right lane, you drive in the left lane, and then at the very last moment you cut and go to the right. So I'm pretty sure if there are autonomous cars in the right lane, they will never turn right because all the people will be passing them going on the left lane. And another example is I worked in a shipyard where there is about a few thousand cars on the parking lot, and they all want to get out of the parking lot as soon as possible. However, that requires a lot of skill and a lot of aggressiveness to get out as soon as possible. I'm pretty sure that the autonomous vehicle will be the last one exiting this parking lot.
Okay, thank you. So it was more like a statement than a question. Do you have really a question for our panelists? Lucas. Who is next?
So this is a question for Sasha. My name is Lucas Nolders from the Netherlands Academy of Technology and Innovation. Thank you for your fascinating story. While we were speaking, I sent a picture of one of your slides to my sons in the Netherlands. You immediately responded with, Rimac is amazing. Rimac is the absolute dream. I'm so jealous.
Thank you.
That you are going to visit their factory tomorrow. But that's not my question. So I was impressed by the sensors that you showed related to driver monitoring. So the EEG headset, the eye tracking, say that is very relevant to the situation that you were sketching, where the car will have dual function. On one hand, it's an autonomous vehicle that demonstrates to the driver what the car is capable of, but then the sports car hands over to the driver, because you don't buy a 2 million euro sports car and not drive it, right? You want to be on the steering wheel. So you do see a permanent role for the driver there. In, say, mainstream vehicles, we see the arrival of built-in driver monitoring sensors, such as eye tracking, which are becoming mandatory due to European legislation. Do you see this type of sensors and, say, even more advanced cognitive load monitoring devices being built into your vehicles, into the production vehicles, and becoming part of the commercial car in the end? Or is this a temporary deployment in the research phase?
Okay, thank you first for your comments, and yeah, that's a good question. Of course, our vehicles are for drivers, right? You do not put such type of money to not drive. We just want to find a way to support the enjoyment of driving, right? To have fun and to master the vehicle. But when you look at that in terms of technology, it opens the possibility to a lot of other companies, because most of the car manufacturer has a sport division, and some car manufacturer has racing in their DNA. So there's applications to other companies of such technologies. Regarding the driver monitoring, yeah, we use it for two purposes. One is for teaching, for example, understanding where is the gaze, right? Understanding if there's some drowsiness, for example. That's a safety issue, but understanding where is the gaze, we can use it for teaching. For example, while you are driving, we can teach you that you need to look at the second corner and not the one that you are driving into, right? And then ensuring and giving you a feedback in the helmet if you are where you are looking is right. But at the same time, you have this safety scenario where if you pass, if you close your eyes too long, if you lose attention, we will automatically take over. So that's a safety. And there's a lot of applications in a vehicle in the future, and that's mandatory for level 3 and and level 4, level 5. It's a different thing, but yeah, but that will be more called cockpit monitoring than just driver monitoring. But yes, the application is not only for research, but for products.
Well, thank you. Are you also using these, say, eye tracking techniques for a user interface designing the dashboard, instrumentation and displays, and evaluating what is the optimal way of presenting car information to the driver and where to present it? Because I see an interesting development that, say, classical cars have all the instruments behind the steering wheel, so you look through the steering wheel at your odometer and the rotation, the acceleration meters, whatever. Modern electric vehicles often have a large computer display in the middle of the car, in the center of the car, which forces you to look to the right in order to read all that information, which inherently means a loss of attention to the roadside view. So it's a more tricky human system interaction than the classical simplistic displays behind the steering wheel, where you didn't have to take your eyes off the road in order to read your fuel level. What is your take on that?
If you can answer briefly, Sasha, please, because we are all in our coffee time. I think Professor Mana is patiently waiting for his question, so if you can be brief. So one more question and then we are done and we are going to have a coffee.
Yeah, very briefly, there's a lot of work into this area, as you mentioned, I'm aware of. We are not particularly in Rimac working on that aspect, but I know there's a lot of work in terms of user experience inside the cockpit, yeah.
So
Okay.
in a racing competition, let's say the car which wins is made by your Rimac. So who gets the prize, the driver or the company?
Yeah, very good point. No,
But actually, at the end, is the driver, right? Because the autonomous labs are just to help the driver to understand what he has to do. So he keeps his hand on the steering wheel, and he feels the torque while cornering and so on. But at the end, he's driving.
So, well, in that case, if it were the other way, then apart from 10 million driver in India, the likes of Vettel and Schumacher, they also would go jobless.
Yeah.
But there's a reason why I'm asking this. See, in case of electric vehicles, we all are aware why we are going for that. So for any change, there has to be a reason why, a motivation, why we are going for a change. So in case of autonomous driving, is it safety that's the biggest driving force, or what exactly is?
Yeah, you can see us bringing active safety at a high speed, right? Which is not what most of the companies are working on today.
Okay, thank you very much. Please don't run away after the panel. I think people will like to ask some questions during the coffee time. I think this discussion was very interesting, at least for me, and we can continue in the lobby. Thank you.